So an I2C transaction, the structure of a transaction means the sequence of zeros and ones that you expect to see on the two lines, the data line and the clock line, in order to send data, to write data, or read data. Okay? So I'm going to go over what the transaction looks like in detail over time. So what is expected on what ones and zeros sequence is expected on those two lines. So one thing to note is that in I2C, every transaction is either a write transaction, meaning the master is writing to the slave, sending data to the slave, or it's a read transaction, meaning the master is going to receive data from the slave. So every transaction starts off with a start condition. A start condition is a condition on the two signals, the SDA and SCL, that indicates the beginning of the transaction. I'll show you what that is on the next slide. So the start condition is needed. Once the start condition happens, the master creates a start condition on the bus, and then the slaves are all listening to the bus, and they look for the start condition. When they see the start condition, they essentially perk up their ears. They start listening because they know that a transaction is about to start. So after the start condition is sent, then you've got to send the address. So every slave on this bus has an address, a known address. And the addresses are 7 bits long. There's also another variant of this protocol where addresses can be 10 bits long, but right now let's say 7 bits long. So you got this 7-bit long address that's associated with every slave, and every slave knows their own address. So the master, when it's sending data to a particular slave, starting a transaction with a particular slave, it has to send that 7-bit long address on the wires, right? One clock cycle at a time. So it sends on SDA line, it sets, say the address is 0000001. So it puts that sequence on the SDA line one clock cycle at a time, one SCL. So the first SCL clock, you'll have a 0. The next one, you'll have a 0, and so on. It puts them on one at a time. And then, in addition to the address, there's one more bit that is a direction. Okay? So altogether, the address and direction make up a byte. It's 8 bits altogether. So 7-bit address plus a 1-bit direction. And the direction it's just a single bit, 0 or 1, that indicates whether this is a read transaction or a write transaction. So what happens is at the point when the address and the data direction are being sent, the slaves are all listening for the address. They receive the address bits one at a time. Then once they receive all 7, they compare those address bits to their own address. And if it's a match, then they continue to interact in this transaction. And if it's not a match, then all the rest of the slaves, where it's not a match, they just go to sleep and forget about this transaction and wait till it's over. Okay, so once you've sent the address and the direction, then there's a data byte, or a set of data bytes that can be sent. Now, if this is a write transaction, then you send as many data bytes as you want to write. You want to write 10 bytes, you send 10 data bytes. If this is a read transaction, then what happens is the slave has to send bytes back, but as many bytes as it as are needed to be read, right? So there's a sequence of data bytes that happen. And data bytes keep getting transferred until finally there's a stop condition. The master says, okay, communication over, and it sets a stop condition, sends that on the data line, the SDA line. And the slave recognizes that and then stops the transmission. So that's the structure. And just to look at the start of this, the beginning of this, we talked about a start condition. So a start condition and a stop condition. Here's what they look like. This is how you start and stop any transaction. So there are two lines, SDA and SCL. The SDA line, if it falls, if there's a falling edge on that line, so you can see the SDA line is high, it goes from high to low. If that happens while the SCL line, the clock line, is high, then that's a start condition. Now, stop condition is the reverse. The SDA line goes from 0 to 1 while the clock line, the SCL line, is high. So that's a stop condition. So when the master wants to start a communication, the master drives SDA from high to low, while it's driving SCL high, and if it wants to stop the communication, then it does the opposite. It drives SDA from low to high while the SCL is high. So start condition is falling transition on SDA while SCL is equal to 1, and stop condition is a rising transition on SDA while SCL is equal to 1. Thank you.